In this lesson, we are going to investigate parallel lines and perpendicular lines. On the left-hand side of the screen, you can see that the green, black, and red are all parallel. When we look at the slopes of parallel lines, the rise over the run, they're all the same. 4 over 6 is the same reduced as 2 over 3. They're all in the same ratio rise over run. So we can say parallel lines have the same slope. Perpendicular lines form a right angle. They create a 90-degree angle between each other. When we calculate the slope of the red line, 4 over 3. We calculate the slope of the black line, 3 over 4. They are reciprocals to each other. Also, the red line is falling left to right and the black line is rising left to right. So the red line is a negative slope while the black line is a positive slope. That is why we say perpendicular lines have opposite reciprocal. If one is falling, the other is rising. Reciprocal meaning the rise becomes the run becomes the rise. Take a look over here, the same thing happens. The red is negative 1/3, the black is 3 or 3 over 1, positive. They are reciprocals and opposite signs. Therefore, the two lines meet at a 90-degree angle. We can see if we know the slope of a line, we also know the slope of every line parallel to it. All slopes are just exactly the same if they're parallel. If we know the slope of a line, we also know the slope of a line perpendicular to it. We just take the slope, take its reciprocal, change the sign. Take the reciprocal, change the sign. Remember, the reciprocal of 1 is always 1. So you just take the reciprocal of 1, change the sign. The reciprocal of 0 is undefined. You are not allowed to divide by 0. That should also make sense because any line with 0 slope is horizontal. Therefore, any line perpendicular to it is vertical. All vertical lines have undefined slope. So 0 and undefined are perpendicular slopes to each other. 1/2 becomes negative 2 over 1. Once we have it over 1, we don't need to write the over 1. We just write negative 2. If we know two slopes are parallel, but we're missing one of the rise or the run of a slope or one of the parts of the fraction, well, we know when slopes are parallel, they are the same. So we can just say that negative 6 over k is the same as 3 or 3 over 1. And then we could just solve a proportional situation in any which way. Oh, I want to get from 3 to negative 6 by multiplying by negative 2, so I do the same. Or we could cross multiply. 3 times k equals 1 times negative 6. Divide both sides by 3. Oh, k is just negative 2. If k is negative 2, I get a slope of 3. This k doesn't always work out to be a nice integer number. For example, here, this one isn't so easy to solve by figuring out what we need to multiply by. When you have negatives, just move the negatives into the numerator and cross multiply. Negative 6k equals negative 75. Divide both sides by negative 6. A negative divided by negative becomes a positive. 25 over 2 reduced, or we could say 12.5 is what k needs to be. 12.5 rise as compared to 15 run would give you the same steepness of line. What happens if we don't know k, but instead of the slopes being parallel, they're perpendicular? Well, if they're perpendicular, this slope doesn't equal 5 anymore. This slope equals 5's opposite reciprocal. So if this slope equals 5's opposite reciprocal, we could just do the same thing. We say it doesn't equal 5, but we take 5's opposite reciprocal just as we did before. We have a nice little equation in which we can cross multiply. Divide both sides by negative 5, and k is 3/5. If k is 3/5, then we get the opposite reciprocal or perpendicular slope. Same thing here. If you ever have a negative, the negative, transfer it to either the numerator or denominator. I like to just always transfer it to the numerator. What you want to do then, oops, I'm writing without thinking, here we go. I want to keep the 6 over k and make it equal to the other slope's opposite reciprocal. I make it to the other slope's opposite reciprocal, and then I can make them equal and solve. 3k equals 12. Oh, divide by 3, k equals 4. So that's how you can find a missing piece of slope if you know they're parallel or perpendicular. What if I give you an equation of a line and say, here's a line, can you find the slope of any line parallel to this graph? Well, if it's parallel, it has the same slope. Well, what is the slope of this line? Well, I don't know because it's in general form. So whenever we have an equation in general form, we can easily find the slope by converting it into slope-intercept form by isolating the y. Divide by 3, divide by 3. Oh, I can see the slope is right here, mx plus b. So if it's parallel, it will have the same slope. If it's perpendicular to this line, it will have the opposite reciprocal slope. What if we want to find the equation of a line? What two things do we need to find the equation of a line? We need the slope of the line, and we need a point on the line, preferably the y-intercept, but any point would do. So, if it's the equation of a line, we need the slope. Well, I know it's perpendicular to this one, and I know the slope of this one is 1/3. So if it's perpendicular, I need the opposite reciprocal. I flip it and change the sign. Here's my point. I have that. They give it to me. So now, whenever you have a point and the slope, you simply use your point-slope form to find the equation of a line. So y minus y, so whenever you're subtracting a negative, it becomes adding. X minus x, again, you're subtracting a negative. It's not a fraction, so I can go straight to multiplying it in. Y plus 1 is negative 3x minus 18. I don't say if I want it in slope-intercept. I don't say if I want it in general, so I get to choose. Let's put it in slope-intercept. Subtract 1, it becomes minus 19. There is the equation of a line with this slope going through this point. What if it's perpendicular to this line and it has an x-intercept of negative 3? And I want to find the equation of a line again. Remember, whenever I want the equation of a line, I need a point, preferably the y-intercept, I don't have it, and the slope. Well, again, whenever I see the word perpendicular, I think slope. It's the opposite reciprocal slope. So what is my slope? I don't know. So I need to convert into slope-intercept form. Once it's in slope-intercept form, negative, remember when there's no number in front of x, it's a 1. Negative 1/2 is my slope. So if it's perpendicular, I'm going to flip it to 2 over 1 and change the sign. What's my point? What's an x-intercept of negative 3? Well, it's a point right there. Remember, the x-intercept is just the value of x when y is 0. It's intercepting the x-axis at that point. So the point has an x-y coordinate. And then again, I would use my y minus y equals m times x minus negative 3, which becomes plus 3. Y minus 0 is just y. Multiply the 2 in. And there you go. Slope-intercept form. If I had to put it in general form, I could do that by moving my y to the other side and leaving 0. And that's how you find the equation of a line.